Python 3.9 was released earlier today as of filming and included 4 updates to the math module, and in this video we will run through them. There's an update to the greatest common divisor function, and 3 entirely new functions, least common multiple, and 2 similar ones that relate to floating point arithmetic, math.nextafter, and ULP, which stands for unit in the last place, or some might call it unit of least precision. So let's run through quickly what each of these 4 updates means for the math module. First, what is new with the greatest common divisor function? Well, prior to 3.9, you could do the greatest common divisor of up to 2 integers. So you could put in 2 integers, let's import math, and you could put in up to 2 integers, and I'm just going to make it a little bigger, and it will find the greatest common divisor between those 2, that is to say the largest number that cleanly divides both of them. So you could do math.gcd of, say, 2912 and 8320, and you would see that the greatest common divisor between those is actually 416, because 2912 divided by 416 is going to be 7, and 8320 divided by 416 is going to be 20. So now with Python 3.9, you can actually add as many arguments as you like to this function, and it will still work. So unlike before, now you can do something like this, math.gcd of, and let's throw back in these 2, and then let's add a third one, and let's do 3360. And so the greatest common divisor, that is the largest number that will cleanly divide all 3 of these now, is going to be 32. Okay, so if you do like 3360 divided by 32, you see it's 105. It all works out, and it's the biggest number that cleanly divides all 3, so that's a big improvement to the GCD function. Next we have math.lcm, and this one is brand new, and it will give you the least common multiple. So inside these parentheses, it does take integers, and a multiple of a number is the product of that number and an integer. So for example, the multiples of 3 are 3, 6, 9, 12, etc. The multiples of 8 are 8, 16, 24, 32, etc. What's the lowest number that these sequences have in common? The lowest common multiple between 3 and 8? Well, let's find out. It is, in fact, 24, and that makes sense, right? Because if you kept counting up by 3s, you'd get to 24. Counting up by 8s, you'd get to 24, and in fact, that's the lowest number that's common between those 2 sequences. And guess what? Just like with the new GCD, with LCM, you can add in as many integers as you like, so math.lcm, and if you do like 3, 8, 34, 293, 19, whatever you want, and there you have it. That's the least common multiple between all these integers. And so those are 2, really mathy, kind of arithmetic-y updates to the math module. There are also 2 updates that are 2 related new functions that deal a little bit with something a little bit more specific and esoteric, which is floating point arithmetic. So floating point numbers are the computer's way of storing decimal point numbers, and important to understanding these next 2 functions, just think about this. If you were to ask a human being what number, including all real numbers under the sun, such as decimals, what number comes immediately after 3, right? Well, it wouldn't be 3.1, would it? Because you could always do, 3.01. But it wouldn't be 3.01, would it? Because you could do 3.001. And you can really always add another, another place here, and all the way to, kind of an infinite amount of point zeros until you are raising 3 by a smaller and smaller and smaller increment. There's no satisfactory answer in in terms of just thinking about it on your own as a human being, without some higher level math, of course. But really, you could that's not going to be satisfactory to a computer. A computer only has limited space, and so to a computer there actually is going to be some floating point number that comes immediately after 3. And that's kind of where we get our next two functions. First is math.nextafter, and just like it sounds, it gives you the number that comes next in floating point, either the next one or the previous one, as we'll see. So here we are going to put in, as our first argument, some number. Let's keep going with for 3. And then comma, and then as our next argument, we're going to put in either something greater than 3 if we want to get the next highest floating point number, or something less than 3 for the next lowest. And so one easy way to do it and to think about it is just to use math.inf, which is our way of representing a positive infinity as a floating point number. And so 3 comma math.inf is just going to say what's the next floating point number available after 3 trending towards positive infinity, right? And you'll see it's 3.000, a bunch of zeros, followed by a 4. And in fact, if you were to do math.nextafter of 3 negative math.inf, it would do it in the opposite direction, and you would see it would be 2.999, etc., 6. And why is this important? You may know that floating point numbers are by their nature imprecise. They're represented in the computer hardware as base 2 fractions, and some digits can't be represented exactly as a base 2 fraction, such as 1/10, which in math as a base 2 fraction would be this infinite repeating number, but in a computer it eventually has to stop. It can't repeat forever, and so you end up having to kind of cut it off at some point, so it ends up being imprecise. And so you end up with quirks like this classic example, 0.1 plus 0.2, gives you 0.3 and some, number at the end, right? It's, even though a human being knows that it should be 0.3, it's actually going to give you this answer that to a computer it's correct, but to a human being we know that it's really not. And so here's where you can use these functions nextafter, and the next one I'll show you as well, ULP, as tools in your toolbox to help you understand and compensate for these floating point arithmetic errors or just quirks. So for example, if you take math.nextafter of 0.1 comma math.inf, just something bigger, and what do you get? You get this 0.1 with a bunch of zeros followed by 2. And what does this tell you about the numbers that, mathematically speaking, would come between 0.1 and this quote-unquote next number? Well, let's see. If you do, 0.1 is equal to, with these two equal signs, and then you see how I copy-pasted all these digits, and now I'm just going to put in a 1 there, because it's 1, to a human being, we would think of this as 1 fewer than 2. So what is it? Is 0.1 going to be considered the same as this, is kind of the question I'm asking with these two equal signs. Well, if it is, it'll say true. If it's not, it'll say false. But it's true. So as far as the computer is concerned, this is a true statement. These two values are equivalent values. And so as far as the computer is concerned, there's no difference. And so that's where math.nextafter, one potential use case of math.nextafter is to kind of understand, hey, what is really the next incremental floating point number, and use that knowledge to understand what's happening with rounding errors and other issues with floating point arithmetic. So what about math.ulp, the unit of least precision, so to speak? This takes as its argument just one number, and it will return the distance between the number you give it and the next floating point number. So to go back to our example of 3, you see it returns this bad boy right here, 4.4, and change times 10 to the negative 16. And I know what you're thinking, hey, we just did it with the math.nextafter, and it was something much cleaner if we did 3, 4 or whatever, and you see it's this. Well, here's another trick. This 0.0004, this is just what the computer's showing you. There are even more numbers behind the curtain that don't make it to your display, that just aren't important enough, frankly, to make it to your display. And so, this really what this is returning, at least when you put in a positive number like this, is this math.nextafter 3, 4. When you put in the math.ulp with a positive number like 3, it's returning the math.nextafter of 3 with some positive number. So if you do math.ulp 3, it's going to be equal to 3 plus, or I'm sorry, no, that's if you do math.nextafter 3 math.inf or whatever, that's going to be equal to 3 plus math.ulp of 3, okay? And so the floating point number, and see, that's true, the floating point number that comes after 3, the very next in line floating point number, is kind of the same as saying 3 plus the unit of least precision after 3, 3 plus, the distance between 3 and this next number. So there are two ways, these are two ways of saying the same thing, even though you see how it gave you a very different kind of display. So those are both pretty useful in all. This Python 3.9 update should give a few useful, very cool things in the math module. And that concludes our quick walkthrough of what is new in the math module in Python 3.9, which is just out as of the date of filming today, October 5th, 2020. More information can be found in the documentation at the link in the description. I want to thank you very much for watching.